Alright, hello everyone. I'm going to start the class now since it's 8:01. So today we're going to be covering surface area and volume. So first, 3D figures. The 3D analog of polygons are called polyhedra. And like polygons, they also have edges and vertices, but they also have faces. So what I mean by that is, this tool. All right. So this point here, the points where three edges meet, they're called vertices, and the points where two faces meet, these lines, they're called the edges. And then finally, these planes, those are called the faces. So now we're going to talk about the 3D version of area. So last class, we learned about area, and it's a measure of how large a 2D figure is. Well, in the 3D analog of that, the amount of space that a 3D figure takes up, it's called its volume. And you can think about it as the amount of water or some other liquid that you could be able to fit in that shape. So, hopefully you've already learned the vocabulary about these 3D figures. I think I learned them in elementary school, but to help in describing them in future questions, I'm going to quickly review them. So prisms are formed by extending a shape in the third dimension. So as you can see, what I mean is that the shape that in the example to the top right, the shape that we're extending is the hexagon that I'm tracing out right now. And what we did is we extended it in the third dimension, which is the lines that I'm drawing right now. So the shape that is extended is called the base. So the hexagon itself, that's going to be called the base of the prism, and they're named by the shape of their base. So as you can see, it's called the hexagonal prism because the base is a hexagon. And you might notice that there's technically two bases because you can think about it as extending this way from this face, or you can think about it as extending this way from this face in the back. And finally, if the base is a circle, if you extend it out in the third dimension, it's called a cylinder. So on the bottom, there's some more examples of different types of prisms. So triangular prism, you can see at the base is a triangle, square, the base is a square, rectangle, etc. Alright, so next we're going to talk about pyramids. So pyramids, they only have one base. As you can see, it's labeled base. And every point on the base's perimeter is connected to a point above the base that's called the apex. So it's also clearly labeled in the picture to the top right. And like prisms, the shape of the base determines what it's called. So in the top right, as you can see, since the base it looks like it looks like a square, it should probably be called a square pyramid. And same thing, just like in prisms, if the base is a circle, it has a special name, and in this case, it's called a cone. And you might notice cones from if you go to any birthday parties, they probably will give you some cone-shaped hats, or on roads. On roads, if there's some issue or a traffic accident, it would probably put out orange traffic cones, and yeah, that's where it's named from. So now we're gonna move on to spheres. So spheres are special in that they're neither spheres are special in that they're not pyramids or prisms, and they're the 3D version of circles. And why would I say that? Well, circles are formed by all points in the plane that are a distance r away from the center point. Right? So, but in the 3D case, it's not limited to just the plane anymore. It's all the points in space that are a distance r away from the center point. And like in the circle, the distance r is also called the radius. And as I said, it's unique in that it's not a prism or a pyramid. So now we're going to move on to the basis of volume. So last class we talked about how area is based on the amount of unit squares with side lengths of 1 unit by 1 unit that could fit in that figure. And volume is based on the 3D version of unit squares, which are unit cubes. And they're also 1 unit by 1 unit by 1 unit. And the amount of them that can fit in the figure is its volume. So I'll give you guys a quick question. I'll see how long it takes for some answers to start coming in, and then I'll go over it. Alright, so I see that a lot of you have already gotten it right, so now I'm going to go over it for those of you that maybe haven't gotten it yet. So what we do, well, first of all, you can just simply count the number of unit cubes, but there's an easier and faster way. So you can notice that there are 3 times 4, which is 12 unit cubes per layer. So what I mean by layer is, I'm going to try it. Yeah, so this is what I call a layer. And as you can see, there's 3 over here. There's 3 per like row, I guess. And then since there's 4 rows, there's going to be 12 of them per layer. And since there are 5 layers, you multiply 12 by 5 to get that there are 60 unit cubes in this rectangular prism. And so then the volume of this rectangular prism is going to be 60 units cubed, but I don't really care if you add the units cubed part. So now I'm going to move on to a general formula for prisms. So as I said, some of you probably noticed the faster way to find the volume instead of just counting the cubes, and you can find the number of cubes per layer, and then you multiply by the number of layers to find the total number of cubes. And so in the case of a rectangular prism with side lengths of A, B, and C, a base, like assume that A and B are the side lengths of a base. The base's area, because it's a rectangle, it's just the product of the side lengths, so it's A times B. And then because the height is C, the final volume is going to be A times B times C. And some of you might notice that there's actually 3 possible bases that you can choose to use for a rectangular prism. It could be either A and B, or A and C, and then finally B and C. But because the height is always going to be the third value, the volume is always going to be equal to A times B times C, since multiplication is commutative and associative. And finally, this is just, the first half was just for rectangular prisms, but in the final sentence, it's very important to remember that for all prisms, its volume is going to be equal to the area of its base multiplied by its height. So here's a quick question. I'll give you guys, I'll wait until you guys, like, some answers start coming in, and then I'll go over the answer. Alright, so some of you have already sent me the correct answer, so now I'm going to go over it. Well, let me see something else. Oh, okay, if you guys need more time, I'll just wait for maybe 5 more minutes. Or earlier if you want me to. Alright guys, so, I mean, if you want a break, we're gonna have a 10-minute break, like, soon. But, for those of you that are bored, I'm just going to go over the answer now. So, well, first of all, you can try finding the area of the base by using Heron's formula. But if you're clever, you notice that there was an easier way. So, you notice that using Pythagorean theorem, 25, which is 5 squared, plus 12 squared, which is 144, is equal to 169 equals 13 squared. So the base is actually a right triangle. And if you have that, then you know that its area is easy to find. It's going to be 1/2 times 5 times 12, which is 30. And then, if you multiply the area of the base by the height, you get the volume of the triangular prism, which is 210. And so those of you that got 210, congratulations, I guess. So here's another question. This one's pretty difficult. Again, I'll wait until some answers start coming in. So yeah, then I'm going to go over it. Alright guys, so I see that a lot of you have gotten it, so I'm going to go over the answer now. Well, first, the volume of the unknown object is going to be equal to the difference in the total amounts of volume in the cylinder between before it was dropped in and after it was dropped in. So before it was dropped in, the volume of the water, you calculate it. First, you calculate the area of the base, which is r squared times pi. So it's going to be 3 squared times pi, and the height is 6. Um, so before it's dropped in, the volume of things that are in the cylinder is 54 pi. But after it's dropped in, the water level rises to 9. So same thing again. The base is still going to be 3 squared times pi, and then the height is now 9, so it's going to be 81 pi. So, uh, so yeah, that's how much total volume is in the cylinder after the object is dropped in. And so, if you find the difference in the volumes, you get that there was a 27 pi difference in the area in the volumes. So the volume of the mystery object is going to be 27 pi. And so it's about halfway through, so I'm gonna give you guys a 10-minute break. Alright guys, I think it's been enough time after your 10-minute break, so now I'm going to continue on. So now we're going to talk about pyramids. So unlike for a prism, deriving the volume for a pyramid might be difficult. And however, I'm just going to tell you that it's 1/3 of the volume of the prism that would be formed with the same base and height. And that just means that the volume of the pyramid is equal to 1/3 times the base area times the height. And this is because you can fit 3 pyramids in the space of the prism with the same base and height. And on the bottom here, here are some examples of pyramids so that you can see what they look like. So here's a question. Given that the volume of a cone, in case you forgot, it's a pyramid with a circular base. If it's 20 pi, find the product of the radius of the base squared and the height of the cone. Alright, so I've had some correct answers come in, so I'm going to go over it now. So what you do is you use the fact that the volume of any pyramid is 1/3 times the base area times the height. So the volume of the cone, it's going to be 1/3 times pi r squared, where r squared is the radius of the base circle times the height. And so you set that equal to 20 pi, and then you divide both sides by pi and multiply both sides by 3 to get that the radius squared times the height is 60. And so you notice that you don't actually need to find the values for the radius squared and the height. And in fact, there are actually like there's actually infinite possible combinations for them. But since the question it just asks for the product of the radius of the base squared and the times the height, you get that at 60. So now we're going to move on to spheres. So the formula for the volume of a sphere is 4/3 pi r cubed. And well, because to derive this, it requires calculus, and that's beyond the scope of this course, so I'm not going to derive it. And so here's a question. I'll also wait until some answers come in, and then I'll go over it. Alright, so I see that some of you have gotten the answer, so now I'm going to go over it. So, you set the volume of the cylinder in terms of the radius r and the height h. It's going to be pi r squared times h. And the volume of a sphere in terms of the radius r is going to be 4/3 times pi times r cubed. So you set them equal to each other and solve. So what you do is you divide both sides by pi and also r squared to get that h equals 4/3 r. And that's the answer. And so now we're going to talk about surface area. So surface area is the amount of area that is exposed to the outside. So you can think of it as how much paint you would need to cover something completely. And well, how do we find it? You just add up the areas of all the faces of the figure. And for prisms, it's not difficult because you can just find the areas of the bases and add the lateral faces. And lateral just means that the faces that are not bases. So it's going to be like the rectangles. And as I said, since all the lateral faces in prisms are rectangles, it's easy to do. So here's another question. It should be pretty easy, so I'll just wait until some answers come in once again. Alright, so a lot of you have gotten it, so now I'm going to go over it for the rest of you. So there are two faces each of a 3x4 rectangle, a 3x5 rectangle, and a 4x5. And what I mean by that is, well, here's the 3x4 face, and there's another one on the bottom. There, okay, yeah, so, right. And then, here's a 4x5 face, and there's going to be another one behind, which is right here. And then finally, there's going to be another two of a 3x5 face. There's one here, and there's one in the back, which you can't really see. So, since there's two each of them, you just add up the areas of all of them. So, the sum of the areas, it's going to be 2 times 12, in parentheses, 12 plus 15 plus 20. Since there's two 12s, two 15s, and two 20s, and so the final surface area is going to be 94 units squared. And so now we're going to move on to the surface area of cylinders. Well, how would you find the surface area of a cylinder? You can't really add up the area of the sides, like the lateral faces, since it doesn't really have any. So instead what you do is you think about unrolling the cylinder, and with that you would create a rectangle with width equal to the circumference of the circular base and height equal to the height of the cylinder. And so what you do instead is that you find the area of this rectangle, and then you add it to the area of the bases. So the bases are circles. If they give you the radius, you should be able to find them. And then for the lateral face or the unrolled face, the width is going to be 2 pi r, since the circumference of a circle is 2 pi r, and the height is going to be h, which is just equal to the height of the cylinder. So yeah, so Hopefully you guys will remember this. And so now we're going to move on to pyramids. So if you try to find the surface area of the pyramid, it's difficult because, well, you can't directly find the height of the triangles. I mean, you can. So you would need to find the height of the lateral faces, which are the triangles. And so what you do is you find the height of find the length of the slant height, which is the letter S. You can see. So I'll try it. Oh god, that's not good. All right, so the slant height is going to be this line, and in this picture it's denoted by the letter S, and it's the distance along the face, along like these triangular faces from the middle of the base to the apex, and the apex is the point on the very top. And so if you sum the area of those lateral faces, it's called the lateral area, and the surface area of the entire pyramid is found by if you add the lateral area with the area of the base. So if you notice this right triangle, it's a pretty big hint as to how you would be able to find the height of these triangles, or the lateral or the slant height. And then for the base of the triangle, well, you would just use the side lengths of the base of the pyramid as a whole. So here's a question. Find the slant height and lateral surface area of a pyramid, like as a number, as in don't include any variables in it, variables in it. If the height is 12 and the side length, or A, is 10. Alright guys, so for the sake of ending this class on time, I'm going to go over the answer. And some of you already sent me the correct answer, so good job. So what you do is to find the slant height, you can use the Pythagorean theorem on the right triangle. So so on the right triangle. So the slant height, that's going to be the hypotenuse of the right triangle with legs of length of the h, which is the height, and r, which is going to be half of a. And well, r is going to be half of a because well, you can see that if you shift r so that it's on the side, it's going to be half the length of a. So given that a is 10, half of a is going to be 5, and h is going to be 12. So you get that the squared, the slant length squared is 13. So the slant height is 13. And then after you have the slant height, you can find the area of each of the lateral triangle faces. Since the slant height is going to be the actual height of those triangles, and the base is just going to be the side length of the base of the entire pyramid, which is a, and that's 10. So each of them is going to be 1/2 times 13 times 10, which is going to be 65. And then, since there's 4 of them, you have to multiply 65 by 4. And so the lateral surface area is going to be 260. And just remember that lateral surface area means that it doesn't include the base. And if it did, the entire surface area would be 360 because the base is a square and 10 squared is 100. And 260 plus 100 is 360. So now I'm going over cones. Well, find the area of the base of the cone, that's not hard, but how do you find the lateral area? Well, if you unroll like the sides of a cone, it's going to form a shape that you see on the right. And so that where C is the circumference of the base and L is the slant height. So the area of this is just the sector of a circle. And so C is the length. So C over 2 pi L, that's going to be the proportion of the circle that this contains. Then you multiply that by the area of the whole circle to get that the area of the sector is 1/2 times CL. And then if you plug in C as 2 pi r, since it's the circumference of the bottom base of the cone, if you plug that in, you get the lateral area of a cone is pi times r times L, where L is the slant height and r is the radius of the circle that's at the bottom of the cone. And since there's not enough time, I'm just going to go over this question. So it asks for you to find the radius of a cone if its lateral surface area is 20 pi and its height is 3/4 of its radius. So you use the formula that the lateral surface area is pi times the slant height times r, and you remember that the slant height is equal to the square root of r squared plus the height squared. And since you know that the height is 3/4 of the radius, you substitute h as 3/4 r, and then you find that the height then you find that the slant height is equal to 5/4 of r. And so pi times 5/4 of r times r equals 20 pi. You divide both sides by pi and multiply both sides by 4/5 to get that r squared equals 16. So r is equal to 4. And final slide, the surface area of a sphere is 4 pi times r squared. And the way to derive this was found by Archimedes because he found that the surface area of a square is equal to the surface area, the lateral surface area of a cylinder that also has a radius r and the height 2r. Yeah, so the height of the cylinder would be 2r, and so the circumference of the base circle would be 2 pi r, and the final area is going to be 2r times 2 pi r, which is 4 pi r squared. And so that's it for this class. I hope you guys enjoyed it. And next Thursday is going to be the last class for this course, and it's going to be a review of everything we covered. So if you feel like you understood all of it, you don't have to join for that class. And anyways, I hope you guys have a good day.